All right, my friends, let's see how it went. Okay, so getting started on your proof. Remember that since we're proceeding with the mathematical induction proof, the first thing is to do your basis step, which is where you show your claim is true for n equaling 1. So if n was equal to 1, then your first partial sum on the left side would just be the 3. And then on the right side, you would just be putting a 1 in for all the n's. So, and we're hoping that the 3 equals what you'd get by putting 1 in for all the n's. So, okay, so now let's simplify it. 4 times 1 is 4, minus 1 is 3, 3 times 1, yep, it's true. Okay, so we just passed the basis steps. So with our analogy, we just showed you can get your foot on the first rung of the ladder. All right, well on our way. Okay, now let's go to the inductive step. Okay, so the inductive step has 2 main pieces. So first, your assumption. So we assume that there exists some k value from the natural number set such that our claim holds true when n is equal to k. That is, okay, so here's our assumption. Our assumption is that S sub k, which term by term, and we're not arguing the term by term side, okay? That's not the part we're arguing. So here's the sum of the first k terms on the term by term side, and then we're assuming that that would equal the formula side where your n is just a k. Okay, so we're assuming that your claim is true for n equaling some k value. Okay, so now all we must show is that our claim also holds true for n equaling k plus 1. Okay, so let's get started on exactly that. So the sum of the first k plus 1 terms, what would that equal? Well, on the term by term side, that would still equal 3 plus 11 plus 19, and you keep adding. The sum of the first k plus 1 terms would still have the kth term in it. It would just also have one more term. It would have the k plus 1 term in it. And the k plus 1 term would be just 8 times k plus 1 minus 5. Okay, how did I get that? You could go right here where they have the nth term defined and replace n with k plus 1. It is that easy. Now, what is our goal? And this is a scratch work thing. This is for you to know kind of what you're aiming for. Our goal is to show that all this term by term stuff that I have right here, that I could get that to simplify down to be this equation side up here, just where n is equal to k plus 1. So let's replace all the n's with k plus 1's up here. So you'd have k plus 1 for the n there, and then you'd have times 4 times k plus 1 minus 1. That's your ultimate goal. Now I'm going to simplify that just a little bit to kind of show like what would my step right before it look like. And so that would look like, let's see, 4k plus 4 minus 1, 4k plus 3. There we go. So this is your ultimate goal, and then this is what it would look like probably right before you're about to get your ultimate goal. Okay, so now let's come over here and see if we can get that. So the next thing you always do, once you write the sum of the first k plus 1 terms on the term by term side, then you use your assumption and you substitute, oopsie, sorry. You substitute the first k terms in with that formula. So that means you can replace all the way up to here with k times 4k minus 1. And then you just have this guy left to add in to get up to the k plus 1 sum. Okay, Now, let's simplify this. Let's see, what's the best way to simplify this, do I think? Probably just go ahead and distribute 4k squared minus k plus 8k plus 8 minus 5, which would be plus 3. And then that would be 4k squared plus 7k plus 3, I think. Now let's go ahead and factor that. So we'd have 4k times k. Let's go with 3 here and the 1 here. Boom, boom. Okay, now compare this to my scratch work over here about what my goal was, and notice that I basically have this little step right here, and now I just need to like kind of unsimplify it a little bit and show that it's just that sum formula up at the top where instead of n's you have k plus 1s. So for starters, I think I'm just going to flip the multiplication around, k plus 1 times 4k plus 3. And then you're going to see me unsimplify 4k plus 3. So this would equal k plus 1 times 4 times k plus 1 minus 1. There we go. Therefore, our conclusion is S sub n, which was defined as 3 plus 11 plus 19, all the way up to 8n minus 5, is indeed equal to n times 4n minus 1. And that would be true for all n from the natural number set. And we proved that by mathematical induction. So mathematical induction proof, as you can see, ends up looking kind of like a paragraph proof. And then it just has your basis step and then your inductive step. Remember, your inductive step has 2 pieces. It has your assumption, and then it has your burden of proof, which is showing that if, assuming that your formula works for n equals k, that it would also work for n equals k plus 1. All right, my friends, tomorrow we're going to start with this example right here in the next part of the videos, but I think this is a perfectly good place to stop for today. Take care, everybody.